this article about Google's Willow chip, it's pretty mind-blowing. A computer that can solve a problem in minutes. Something that would take a supercomputer the entire lifespan of the universe. How is that even possible?
Well, it's definitely a fascinating development. We're not talking about just a slightly faster calculation here. It's a completely different approach to solving problems.
Right, and I think for our listeners, most are probably familiar with like the basics of quantum computing, but this leap in error correction, that's the real story with Willow, right? It's doing things that were considered impossible, like theoretically impossible just a few years ago.
Exactly. Yeah, for years, the biggest hurdle in quantum computing has been noise, or you could say errors, and qubits, which are the building blocks of quantum computers. They're incredibly sensitive. Even the slightest interference can cause errors in calculations.
Yeah, I'm picturing these qubits like incredibly fragile things. What did Google do to make them more stable?
Well, they've made several advancements. So Willow combines 105 physical qubits, and they're using this cutting-edge error-correcting technology. This allows them to create what are called logical qubits, which are essentially groups of physical qubits all working together to kind of maintain the data integrity. You can think of it like a team. If one member makes a mistake, the others can compensate.
So it's like having a built-in backup system.
Precisely. And this is where Google achieved a major breakthrough. They've managed to reach what's called below threshold error rates, meaning that as they add more qubits, the system actually becomes more reliable, not less.
That's a game changer. So how do they actually accomplish this?
Well, there were some key improvements to both the hardware and the software. For example, they refined the calibration process for the qubits. They also used machine learning to better identify and correct errors. And they even improved their device fabrication techniques to create more stable qubits in the first place.
So they kind of tackled the problem from all angles. One thing that stood out to me in the article was the mention of coherence times. Can you explain what exactly that means?
Sure. Coherence time refers to how long a qubit can maintain its quantum state, that special in-between state, you could call it, that allows for things like superposition and, all the magic of quantum computing, basically. The longer the coherence time, the more complex the calculations a quantum computer can handle.
So longer coherence time basically equals more computing power.
In essence, yes. And with Willow, Google's achieved coherence times of almost 100 microseconds, which is 5 times longer than their previous Sycamore chip. That's a significant improvement.
Okay, so we've got these more stable qubits with longer coherence times. But how do we know that this actually translates to real-world performance?
That's where the random circuit sampling test comes in, or RCS for short. It's a standard benchmark in quantum computing. It's designed to push these machines to their limits.
So it's like a quantum obstacle course. What did Willow have to do for this test?
Essentially, the RCS test involves getting the quantum computer to perform a series of random operations. And then you measure the output. It's a task that's incredibly difficult for classical computers, but well suited to the unique abilities of quantum computers.
And how did Willow perform?
In a word, spectacularly. Willow completed the RCS test in under 5 minutes. Now, to put that in perspective, the fastest supercomputer on Earth would take an estimated 10 septillion years to perform the same calculation.
10 septillion years. That's longer than the universe has even existed.
Yeah, it really highlights the potential power of quantum computing. We're talking about a completely different scale of computational power.
It definitely feels like we're witnessing like a pivotal moment in technology. Benchmarks are one thing. But what about real-world applications? What can we actually do with a quantum computer like Willow?
Well, that's where things get truly exciting. Quantum computing has the potential to revolutionize many fields, from medicine to material science to artificial intelligence. Imagine being able to simulate the behavior of molecules at the quantum level. This would allow us to design incredibly precise drugs, or even discover entirely new materials with unprecedented properties.
That's mind-boggling.
Yeah.
But I think we should dive into those applications a bit more in the next part of our deep dive.
It's really a fascinating time for any field. Any field that relies on computation.
Yeah, you mentioned drug discovery. Like, what could that look like with quantum computing?
Well, imagine you're a scientist and you're trying to develop a new drug for a specific disease. Currently, the way it works is you have to experiment with tons of molecules, testing each one to see if it interacts with the target protein in the way you want it to.
So it's a very trial and error process, right?
Exactly. It takes forever, and it's incredibly expensive.
Well, but
with a powerful quantum computer, you could simulate those interactions between the molecules at the quantum level, which would allow you to pinpoint the most promising candidates. much faster, and with a higher degree of accuracy.
So we're talking about speeding up the drug discovery process, potentially by years?
Potentially even more. And that's just one example. Think about material science. We could use quantum computers to design entirely new materials with properties we've never even seen before.
Like stronger materials, lighter, more durable.
Precisely. We could revolutionize so many industries: aerospace engineering, construction.
What about AI? Artificial intelligence, how would quantum computing impact that?
Oh, in several ways. For instance, quantum computers could help us develop much more sophisticated machine learning algorithms, algorithms that can analyze massive data sets and uncover patterns that classical computers would never be able to find.
So it's about finding these hidden connections in the data. That could lead to all sorts of breakthroughs.
Absolutely. Think about financial modeling, cybersecurity, climate prediction, all areas where quantum-enhanced AI could have a major impact.
So it really sounds like a fundamental shift in what's possible with computing.
That's exactly what it is. We're moving beyond those limitations of classical computers and entering a new era, an era of computation with quantum technology.
But let's be realistic here for a second. How far off are these applications? Will we be seeing quantum computers in our homes and offices anytime soon?
Not quite yet. Quantum computers are still in their early stages. They require specialized equipment, highly trained personnel, and carefully controlled environments. It's not something that's going to be widely available overnight.
So no quantum computers replacing our laptops next year?
Not in the near future.
Good.
It doesn't mean we won't see real-world applications of quantum computing in the coming years. In fact, companies like Google, IBM, Microsoft, they're already offering access to their quantum computers through cloud services.
So researchers and businesses can experiment with the technology now.
Exactly. It's still early days, but the progress is accelerating rapidly.
It sounds a lot like the early days of the internet. Limited access, but huge potential.
That's a great analogy. Just like the internet transformed our world in ways we couldn't have imagined back then. I believe quantum computing has the potential to do the same in the years to come.
It's definitely an exciting time to be alive. But with any powerful new technology, there are always potential risks. What are some of the ethical considerations that we need to be thinking about when it comes to quantum computing?
That's a crucial question. As with any technology this powerful, there are potential downsides and ethical considerations that we need to address proactively. One area of concern is cryptography. Quantum computers could potentially break the encryption algorithms that we rely on today to secure our online communications and financial transactions.
So our current security measures might not be enough in a quantum future.
It's a possibility, and it's one that we need to prepare for. Fortunately, researchers are already working on developing quantum-resistant encryption methods, but it's a good example of the kind of challenges that we need to be thinking about.
What other potential downsides are there?
Well, job displacement is another concern. As quantum computers become more sophisticated, they could automate tasks that are currently done by humans. This could have significant economic and societal implications.
It's something we've seen before with previous technological advancements.
Exactly. So we need to be thoughtful about how we manage this transition and ensure that everyone benefits from the advancements in quantum technology.
It's a lot to consider, but it sounds like there's a lot of effort going into this, addressing these challenges and making sure quantum computing is used responsibly.
Absolutely. The key is to have open and honest conversations about these issues and work together to find solutions.
It's clear that quantum computing is a game changer, but I feel like we've only just scratched the surface here.
We've covered a lot of ground, but there's still so much more to explore. Perhaps we can shift gears a bit and talk about the people behind these breakthroughs, the quantum pioneers who are pushing the boundaries of what's possible.
Yeah, it really is fascinating to think about. The people behind all of this, the ones pushing the boundaries.
Yeah, who are these quantum pioneers?
Well, it's not just physicists and computer scientists anymore. The field is really attracting talent from all over. Mathematicians, engineers, chemists. I've even heard of philosophers contributing to the evolution of quantum computing.
So it really takes a village.
It does. You need people who can think outside the box, people who can bridge those different disciplines to tackle these really complex challenges.
Yeah, I can imagine there's a lot of trial and error, a lot of dead ends along the way. What kind of mindset do you think you need to thrive in that kind of environment? Resilience is key. Quantum computing is definitely not for the faint of heart. You need to be comfortable with uncertainty, embrace failure as a learning opportunity, and have the persistence to just keep pushing, even when progress seems slow.
That's a good point. It must take a lot of patience and determination.
Absolutely. And a healthy dose of humility. I mean, we're dealing with some of the most fundamental mysteries of the universe here. A sense of awe and wonder goes a long way.
It's like those early explorers, setting sail into the unknown, not knowing what they'll find, but driven by that thirst for discovery. Except in this case, the uncharted territory is the quantum realm.
What a fantastic analogy. And just like those explorers, today's quantum pioneers are charting those new maps, pushing the boundaries of human knowledge, opening up possibilities we can only begin to imagine.
That makes me think about accessibility. Right now, it seems like it's mostly big tech companies and research institutions. With the resources to really play in this space, will it always be that way?
That's a really crucial question. Democratizing access to quantum computing is essential if we want to unlock its full potential. Fortunately, there's a growing movement toward open source platforms and educational initiatives, all aimed at making this technology more widely available.
That's good to hear. So what could that look like in practice?
Well, imagine students in classrooms around the world having access to quantum computers, or startups and small businesses harnessing this power to innovate. The possibilities really are endless.
That's almost like giving superpowers to a whole new generation.
It is, and that's why education and outreach are so important. We need to inspire and empower the next generation of quantum explorers, the ones who will inherit this incredible technology and ultimately shape its future.
So as quantum computing continues to evolve, what are some of the key things we should be keeping an eye on?
Well, there are several areas, I'd say. First, the development of more stable and powerful quantum computers. That's crucial. We need to keep pushing those boundaries in terms of qubit count, coherence times, and error correction.
So building bigger and better machines.
Yes, but it's not just about the hardware. Advancements in software and algorithms are equally important. We need to develop more efficient quantum algorithms, ones that can tackle those real-world problems.
Right, and what about the ethical considerations we talked about?
Those will continue to be crucial as well. We need to ensure that quantum computing is developed and used responsibly, with careful consideration of its potential impact on society.
So it's a balancing act, pushing the boundaries of innovation,
Yeah.
while also ensuring ethical and responsible development.
Exactly. And it's a challenge that requires collaboration between scientists, policymakers, industry leaders, and the public.
It sounds like there's still a lot of work to be done, but also a lot to be excited about.
Absolutely. We're still in the early stages of this quantum revolution, but the possibilities are truly extraordinary.
Well, this has been an incredible deep dive into the world of quantum computing. It feels like we've only just scratched the surface, but it's definitely left me wanting to learn more.
It's been a pleasure exploring these topics with you.
And for our listeners, thank you for sending us this article and inspiring this deep dive. We hope you found it informative and engaging.
And if you're interested in learning more, there are some great resources available online. A simple search will lead you to articles, videos, even online courses.
And who knows, maybe you'll be the one making the next big breakthrough in this incredible field. Keep asking questions, keep exploring, and never stop learning. Until next time, stay curious.